Hello, Algebra 2 class. We're going to take a look first at our calculator today because we're going to move into what are called inverse trig functions, where instead of finding a number such as 0.645 that is the value of a particular trig function given its angle, we're actually going to find the angle measurement. So we need to make sure that we know how to locate on our calculator our sine, cosine, and tangent buttons, and right above those buttons you're going to see sine. It looks like a -1. It's actually not. That means inverse. Same thing here, cosine, it looks like an exponent -1. It means inverse of cosine, and tangent inverse. So those inverse functions that are notated with that exponent of -1 will give us an angle measurement. So for example, we know that the sine of 30 degrees, our calculator would give us 0.5 because it's 1/2. Okay. So that is given an angle measurement and a trig function finding its value. All right, what happens if we want to go backwards? Well, if we want to go backwards and find out the angle measurement, we would push our second button. So I push second and then I push sine. And notice that -1 that looks like an exponent, but it means inverse. So that inverse function we read as the angle whose sine is, and I'm going to put in 0.5, and that should return 30 degrees. And it does. The angle whose sine is 1/2, 0.5 is 30 degrees. So our inverse functions are going to allow us to get an angle answer for our trig function given a particular value. Let's just try another one just to make sure we've got how this works cleared out. How about the angle whose tangent? So I'm pushing my second button and then my tangent, and it opens up my inverse function. The angle whose tangent is, say, -1. What would we get for that? We get -45 degrees. So we can get all sorts of different answers. These are all going to be the number of degrees because I'm in degrees mode. We will not be using radians today. And so let's see, we could say what is the angle whose cosine is 52? No, actually cosine is restricted to between -1 and 1. So the angle whose cosine is, say, 0.025. What would we get for a response? Oh, there would get a nice degree measurement. Notice that the degrees is an irrational number. It is going to continue on forever. We could round that off to the nearest hundredth, 88.57. That 6 would turn into 7 if we round it off to the nearest hundredth. Okay, so that gives you some familiarity with how your calculator works. Now let's move into our lesson. Lesson 9.4, evaluate inverse trigonometric functions. So our inverse trig functions are asking the question, what is the angle given a specific value of your trig function? Well, here is the issue, though. By the way, everything that you see here in these purple thinking bubbles, you do not need to write on your paper. You just need to be aware of this information. So if I said, well, what is the angle whose sine is, say, 0.5, you'd say, well, 30 degrees. But there's another way we could name that angle. We could find another coterminal angle, 30 plus 360 is 390, or we could say 30 minus 360, even it's -30 degrees. And so there are multiple answers you can give when you say what is the angle measurement, because there's lots of ways to name angles. Because of that issue, we then say, well, let's go ahead and be very specific about which angles we're looking for. So for inverse sine of x, that is, what is the angle given a particular sine value x, we're going to say let's put it in quadrant 1 or 2 only. And that's where we're going to restrict our answers to be. And so that's just so we don't have that confusion of multiple angle answers. Inverse of cosine then is restricted between quadrant 1 and quadrant 2. And inverse of tangent will be restricted between quadrant 1 and quadrant 4. And that way we will get one specific unique value when we're asking that question as opposed to multiple answers. All right, so let's move on into our example problems to see how this works. Note, we will use degrees only to answer all questions in this lesson. Your textbook's going to ask you for both degrees and radians. Ignore all directions that ask for radians in this lesson, please. For our first guided practice problems, we're going to make sure we have our book open to page 557 or our notes in one of our homework lessons where we have page 557 chart giving us trig values for special angles 30, 60, and 45 degrees. All right, so guided practice 1 says to find the angle whose sine is root 2 over 2. So there's our inverse function. Looks like -1. The inverse of sine being square root of 2 over 2 equals what? And we're going to come up with 45 degrees in a minute. Okay, so I'm not going to read this saying the inverse of sine because I think it makes a lot more sense to process this in our brain if we say the angle whose sine is. Okay, so our inverse functions we're going to read as the angle whose sine is. So the angle whose sine is root 2 over 2, well, we look on page 557, and we see on page 557 it says that the sine of 45 degrees is root 2 over 2, and we're done. Okay, and it happens to fall in quadrant 1, our 45 degrees being positive. Sine is y over r, positive over positive. So in this case, what you see is what you get on page 557. The inverse of sine is positive in quadrant 1, so we're done, 45 degrees. Our next few problems will be a little more complicated than that. For guided practice 2, we want the angle whose cosine is -1/2. We want to know what it is. When we look on page 557, you're not going to see 120 degrees. What you're going to see is that the cosine of 60 degrees is 1/2, but we want -1/2. How do we get that? Well, where is cosine negative? In quadrant 1 or quadrant 2? Because remember, we're restricted to between quadrant 1 and quadrant 2 for our inverse cosine. So in quadrant 2 is where our cosine is negative. Remember, cosine is x over r, negative in quadrant 2 for our x over our positive r. So here's our reference angle, 60 degrees. We have to be in quadrant 2. So what is the angle measurement when we're in standard position? Well, it would be 180 all the way around minus 60 degrees equals 120 degrees. So we have to take the 160 off of the 180 degrees to find out from here to here what is that angle measurement. So it would be 120 degrees. Guided practice 3, we want the angle whose tangent is -1. Again, when you look on page 557, it shows the tangent of 45 degrees is 1, but we want -1. Where is tangent negative? Well, inverse tangent is restricted to between quadrant 1 and quadrant 4. In quadrant 1, it's positive, but in quadrant 4, it's negative because, remember, tangent is opposite over adjacent. Negative over positive gives us a negative. So we want to know what this angle is right here. You can either report it as -45 degrees, or you could take 360 minus 45 to get your 315 degrees in quadrant 4. Either way is fine. Okay, guided practice 4, we want the angle whose sine is -1/2. When you look on page 557, it shows that sine of 30 degrees is 1/2, but we want -1/2. Where is sine negative, quadrant 1 or quadrant 4? Because remember, the inverse sine function is restricted to between angle 1 and 4. Well, sine will be negative down in quadrant 4 because sine is y over r, negative over positive. So since we're down in quadrant 4, we can either report our answer as -30 degrees, because we can go down 30 degrees, or we can report it as 360 minus this 30 degrees. So there's our standard position and our positive value for the angle whose terminal side is right here. So 360 minus 30 is 330 degrees. Guided practice 5 takes us into now solving some equations when we are looking for an angle measurement. So we're asked to figure out what is theta in the equation. Cosine of theta equals 0.4. Well, we're going to be using our calculators now. These are not special angles. First, we rewrite this equation so that we are solved for theta. So we're going to rewrite this as an inverse function. We're going to switch the theta and the 0.4, and we're going to write this as inverse cosine. So the angle whose cosine is 0.4 is equal to theta. We want to know the angle measurement that would make this true. So again, we switch these and turn it into an inverse function, and now we're going to use our calculator to work it out. So go to your inverse button, and you're going to figure out on your calculator what is the angle whose cosine is 0.4. And your calculator will return a very long set of digits, round off to the nearest hundredth, and you'll see that we're rounded to 66.42. That would be great if we were only asking for in quadrant 1 or quadrant 2, what is our answer? Well, it would be a quadrant 1 answer, but we're told that we're supposed to figure out that cosine value in quadrant 4, between 270 and 360. So what is the reference angle down here? in quadrant 4, it would also be 66.42, but we're going down, so you can report that as a negative answer. Or you can do 360 minus 66.42 to get the angle measurement as a positive number of degrees. Again, our answer would have been 66.42 if we were asked just for the angle in quadrant 1, but we were asked for the angle in quadrant 4. So we took the answer we got, 66.42 degrees, and we asked what would that cosine be in quadrant 4. Got to practice 6, we're going to go through the same process. The tangent of theta is 2.1. We're going to rewrite this as an inverse function, switch the theta and the 2.1, write it as an inverse. The angle whose tangent is 2.1 equals theta. Plug into your calculator, use your inverse tangent button, and you'll find out theta is 64.54. Well, that's great, except for we need to put the answer between 180 and 270 degrees, and that's in quadrant 3. So our reference angle is 64.54. So to answer the question in quadrant 3, what is that tangent value? You're going to have to take your 180 degrees, and you're going to have to add that 64.54 to get this answer down in quadrant 3, somewhere between 180 and 270. So 244.54 will be our final answer for what is the tangent of theta being equal to 2.11. We must be in quadrant 3. Guided practice 7, the last one of this type. So on guided practice 7, I changed it a little bit from what's in your textbook just to get some more practice here. What is the sine of theta if we are equal to negative 0.23? Again, switch the theta and the negative 0.3 and rewrite it as an inverse function. The angle whose sine is negative 0.23 equals theta. Use your calculator to come up with a value for theta, negative 13.30. That's your calculator answer. But again, we need to look to see what we're told. We're told we have to find our answer in quadrant 2. So here's our reference angle, 13.30. And so we are asked to figure out what would be that angle measurement in standard position. Well, let's see. To get in standard position, we have to take 180 minus this amount because we're stopping before we get to 180 degrees. So our theta will be 180 minus 13.30, and that's equal to 166.7 degrees, because we're told we have to find our answer in quadrant 2. So for each of these, once you find out your theta value, then you have to figure out if that's your reference angle in the quadrant you're given, what would your final number of degrees be? All right, the last three I think you'll find a little less tricky. So here we're taking off the coordinate plane and we're just asking for triangles. What is the value of theta in a particular triangle? But we'll still use our inverse trig functions to answer our questions. So for this triangle here, first we're going to label up our opposite, adjacent, and hypotenuse sides. Start with opposite the right angle, label that your hypotenuse. Next to theta is your adjacent angle. There's your adjacent leg, and the opposite leg will be the faraway leg from the theta angle. So once you have that labeled up, you can write a trig equation that is true. We notice that we have the adjacent and the hypotenuse side labeled, so we're going to use cosine because cosine is opposite over hypotenuse. So the cosine of this theta angle will be adjacent 4 over hypotenuse 9. Now we're going to rewrite this as an inverse function, switch your theta and your 4/9, and write this as the inverse of cosine 4/9 equals theta. Again, I'm going to think of this as the angle whose cosine is 4/9 is theta. Plug that into your calculator, use your inverse function buttons, and you will find out theta is 63.61 degrees. We don't have to worry about finding this on a coordinate plane in a particular quadrant. It's just whatever value we get for theta. Guided practice 12. So on this one, we're given this triangle, label up our sides of our triangle, opposite, adjacent, hypotenuse. We notice that we have the opposite and the adjacent sides labeled, so we're going to think tangent. The tangent of angle theta will be opposite 10 over adjacent 8. Now, technically, you don't have to reduce this fraction because it's not a final answer, but I like smaller numbers when I can easily get them, and this does reduce easily down to 5/4. You could still leave it as 10/8 and it would be fine. Now we're going to rewrite this as an inverse function. The angle whose tangent is 5/4 equals theta. Reverse your theta and your 5/4 when you rewrite it in inverse function form. You could also have 10 over 8 here, and it will work equally well, it'll give you the same exact answer. So in our calculator, we'll figure out what the angle whose tangent is 5/4 is, and it will give you the degrees answer as 51.34 degrees, rounded off to the nearest hundredth. Last one, guided practice 13. We want to know what angle theta is in this triangle, so we label up all the sides, adjacent, opposite, hypotenuse. And then we're going to notice that we have the sides opposite and hypotenuse labeled, so we're going to use our sine function. So the sine of this theta will be 5/12. Rewrite this in inverse trigonometric function form. Switch the 5/12 and theta. Rewrite it as an inverse function. So the angle whose sine is 5/12 is theta. Use your calculator to come up with theta is 24.62 degrees, rounded off to the nearest hundredth. All right, now it's time to move on to your homework and practicing with your calculator. If you have any calculator issues, please contact me so I can make sure that you understand how to find inverse trigonometric functions on your calculator. See you next